Dr. H.S.M. Prakash, the distinguished speaker of today's event, 52nd event of Sambhashane, which is successfully completing 52nd event today. And today's topic is very interesting, important, and informative. The topic is geological truths, perspectives in climate change. Friends, we are all living on the earth. We respectfully call it as Mother Earth, which is the most common and mysterious thing to a mankind. And one strange thing is when we compare the age of the existence of man on this earth and the age of the earth, man is born just a few seconds back on this earth. The earth is mysterious, both outside and inside. Outside, as all we observe, mighty oceans, skyscaping mountains, lush green, dense forests, and lifeless sandy deserts, and the living organisms, and the different environments in all parts of the earth. And inside, the earth is a treasure of gold, diamond, silver, platinum, rare earth elements, coal, water, fossil oil, etc. in its womb. That is why we Indians call the earth as Ratnagarbha Vasundhara, which is a bountiful face of the earth. The earth has a dreadful face also. We will see volcanoes, earthquakes, tsunami causing calamities. And we see hot water glaciers and cold water glaciers side by side. So these are all the inside mysteries of the earth. The mysterious mysterious activities inside the earth and the human activity outside the earth, they are influencing the climate and its change, which is a global concern today. And we are getting an insight from today's speaker, Mr. Dr. H.S.M. Prakash, from the perspective of a geoscientist. Coming to Dr. H.S.M. Prakash, Dr. H.S.M. Prakash is an eminent geoscientist, distinguished writer, and accomplished translator. Dr. H.S.M. Prakash his journey in the field of geology is both extensive and exemplary. He is a first-class holder in MSc Geology of 1978 batch from Bangalore University and a successful candidate of the UPSC Geologist exam in the same year. Dr. Prakash joined Geological Survey of India in 1980 and is a deep geological study and vast exploration cover formidable Satpura mountain regions of Madhya Pradesh and mineral-rich terrain of AP and Karnataka, complex formations of northeast region of Assam. Dr. Prakash played a pivotal role in mineral exploration, contributing significantly to the discovery of gold, diamond, phosphorite, copper, lead, zinc, and rare earth elements. His efforts brought to the light a large deposit of rare earth elements in Linksguru Taluk and Machnuru area of Raichur district of Karnataka. Dr. Prakash served in various capacities in the GSI as an administrator, as a faculty in training senior officers of GSI, as a director technical in the Ministry of Mines, Government of India. He represented India as a member of Indian delegation at World Mining Congress at Beijing, China. Dr. Prakash retired as Deputy Director General from GSI in 1915. Dr. H.S.M. Prakash, he did not stop his intellectual pursuit with his retirement. He undertook an independent, deep analytical study of Kerala Kodagu floods of 2018 and his predictions of reoccurrence of the disaster in 2019 materialized with striking accuracy. His article on this subject, Geological Truth about Climate Change, was published in the Journal of the Geological Society of India. Friends, a geoscientist's career is more or less an expedition of a sailor and a mission of a soldier. Dr. H.S.M. Prakash is a scholar with a PhD from Bangalore University for his research on the genesis of gold deposits in Karnataka. This is the his academic phase of in geology. Dr. Prakash has another phase in literature too. Dr. Prakash's contribution to literature, he translated over 40 works between English to Kannada and Kannada to English, spanning novels, poetry, and short stories for prestigious institutions such as Kendra Sahitya Academy and Kuvempu Bhasha Bharati. His literary excellence has been recognized with several awards, including Aryabhatta Award in 2012 and the Karnataka Sahitya Academy American Kannada English Translator Award in 2014. He has authored a biographical work on Srimati Sudha Murthy, co-founder of Infosys. So let us listen to this multi-talented, distinguished speaker of today's. Welcome, Dr. H.S.M. Prakash, sir. The session is yours.
Thank you. Thank you very much. Good evening, everybody. Am I audible to everybody?
Yes, sir. Yes, sir.
Yes, sir. You are audible, sir. Please.
Okay. Thank you very much for a nice introduction. He told very nice words about Mother Earth, its mysteries and its ways of functioning and several other aspects internally and externally, very well expressed. And also he told a fact that geologist's life is that of a sailor and also that of a soldier. Yes. In fact, our life is almost like a paramilitary life. We live in tents and in camps, in interior places, in thick forests, facing all kinds of hazards. In military, at least there's a line of supply. Here we don't have anybody to help us in interior jungles. So that's the kind of life that we lead in GSI even today. It started in 1851 by one British geologist called Dr. T. Oldham. And today we are 3,000 plus scientists strong. And we carry out various types of geological works all over the country, in remote corners, even in inner areas, very close to the international borders, where ice is not there at least. If it's an open area, people walk up to that point to collect geological information. And also, we have a permanent research station in Antarctica. GSI mans it. So that kind of generation of data and publication and so many other activities we do. And the prime duty of GSI was and also is to locate new mineral deposits, of all kinds. Well, at least a few are known to the people: iron, manganese, chromium, limestone, gold, silver, diamond, like that, chromium, and beyond that, tin, tungsten, and sometimes uranium. Of course, now AMD has come up for that. Rare earth elements. Presently, the country is talking of critical minerals. Critical minerals are very, very important in electronics, defense, medicine, and fundamental science, scientific work. Although certain elements are very rare, they have got some rare properties and they are very much needed in space research and several other fields. So we do search for all these deposits. Presently, this year, we have launched 300 field season programs all over the country with teams of geologists, 2 or 3 in one team, to work in interior places and to locate critical minerals. I have reported a new rare earth element deposit in Lingsugur area. That's a contribution to the mineral wealth of the country from my side. As told by him, some gold and diamond deposits and copper deposits here and there during the course of my work. I was a mineral exploration man basically when I was in service. But after retirement, as you mentioned, I took to literature. In between, this Kerala Kodagu tragedy struck me, and I took it as a suo moto challenge on me to find out the truth behind all these calamities. And I was sure during that time that the explanations offered by various scientists were not convincing. As all of you know, the answers given by certain prominent scientists were climate change. Climate change in terms of carbon dioxide emissions. So, and also deforestation and other aspects, industrialization, urbanization, various aspects were mentioned for the calamity. But I was sure that all these are not the real reasons, because we deal with the history of the earth over 4,500 million years, 450 crores of years, ever since the earth took birth. And since that day to the present moment, what is happening all over the world, in all corners of the world, we are aware. And in between, some changes have taken place. Several changes, major changes like catastrophes. All of you are aware about certain aspects like plate tectonics, continental drift, evolution, then extinction, polar wandering, North Pole becoming South Pole and South Pole becoming North Pole, continental collisions, major earthquakes, major volcanic eruptions, major mineral deposits, gold deposits, iron deposits, on which certain countries depend for their economy. For example, India is very rich in coal, iron, manganese. We are lucky. We are able to build our industrial base based on these natural commodities. Cuba depends on copper. Then Morocco and Nauru, such countries depend on phosphorite. Their economy depends on such major mineral deposits. So oil and natural gas, all of you are aware of it. What is going on in Middle East for the possession of these mineral deposits is very well known. It was part of GSI's work 50 years ago, before ONGC came into existence. Oil India Limited is also doing prospecting and exploration for oil and natural gas, things like that. GSI has got varied challenges and doing fundamental research in geology, various aspects of petrology, study of the rocks, minerals, then environmental geology, engineering geology. For the construction of any major engineering structure in the country, a certificate by GSI is a must. So like that, study of the earthquakes, volcanoes, all these things are jobs of GSI besides climate change. Of course, we have a branch called paleoclimate. We deal with the past climate over the last, say, 450 crores of years, when major changes have taken place, catastrophes. One example to quote is the disappearance of dinosaurs around 65 million years ago. Cretaceous tertiary boundary, what we call KT boundary. The astronomers have given the reason that there was a major meteorite impact, a fall of a major meteorite. That has got limited evidence, but more evidence is there for global volcanic eruptions all over on all the continents. Because of the such volcanic eruptions, lot of volatiles came out, dust came out that covered the earth for nearly 2 million years. It is something unbelievable. 67 million years to 65 million years, there was a dark period. Everything perished, including dinosaurs. Of course, man was not there. Human being appeared only 4 million years ago. After that KT boundary extinction, mass extinction, after a gap of nearly 10 million years, new species appeared. Mammals came into existence for the first time, and then finally man has appeared. It's a long history. So coming to my topic today, what I'm going to focus is the climate change, so-called climate change. This is the current topic all over the world, because there are some vagaries of the climate and there are some disturbances now and then. I call them perturbations, climate perturbations, and not the real change. Real change was dinosaur extinction period, mass extinction. 5 times there were mass extinctions in geological history, and there were ice ages for a long period. And also corresponding to that, after some time, there were long warm periods, long famines. So like that, alternately, ice age and long warm periods have taken place. And we know the reasons. And now what people are attributing, that a lot of carbon dioxide is released, man-made disaster, anthropogenic reasons, vehicular emissions have increased, Industrial emissions have increased. Thermal power plants are emitting a lot of CO2. So like that in the last 30, 40 years, yes, there is some increase. Last 100 plus years, there is an increase. And above what was existing earlier. Earlier, it was supposed to be 330 ppm, parts per million of carbon dioxide. Now it is supposed to be 440 parts per million of CO2. Marginal increase compared to the past. Earlier, nearly 2000, 3000 ppm of CO2 was there in the atmosphere. Okay, that was the period of great volcanic activity. In fact, volcanoes spew out a lot of CO2. Okay, so compared to that, present CO2 levels are not that alarming, but it was made an alarming sign by some vested interests. Vested interests, I should call, I should say so. Going back into the history of the climate change, it all started from Rio de Janeiro conference in Brazil in 1991 for the first time. Some people thought that CO2 is increasing and we should find out the ways of mitigating it. So 1991 and successively, every 4 years there were climate summits, and there are various ideas by people to how to mitigate or how to control the CO2 emissions. So like this, things have changed a lot since 1991. And in between, two persons, Al Gore, Vice President of America, and then our Indian scientist, Dr. R.K. Pachauri. These two people thought of an idea of launching a committee at the global level to think of the ways of controlling the CO2 emission. So they formed the United Nations IPCC, Intergovernmental Panel on Climate Change, and they took a lot of funds from America, billions of dollars for doing research into climate change. It went on and 4 voluminous reports are published. I have read all those reports, and then finally a summary was there. I have gone through that report, and I found that the data that is submitted in those reports, that is all average data. They talk of average rainfall, average temperature, average glacier, increase or decrease, average sea level rise, like that. They have collected data from all corners of the world. In fact, they involved all scientists of all governments in the world, and they were funded. They collected all data in their respective areas, and they collected the data over 100 years. They fed the data to a supercomputer, and the supercomputer, as you know, it gives some models, some projections. So it said by 2020 there will be a sea level rise. And by 2030, 2-degree increase in temperature will be there, global average temperature. And by 2050, 3-degree increase will be there, like that. So I was watching all these things. As a professional geologist, I was sure that carbon dioxide is not the culprit. It's a very, very benevolent gas. It's an innocent gas. More the CO2 in the atmosphere, better the growth of the vegetation, abundant growth of trees and plants. We have seen this earlier in the geological past, especially Permo-Carboniferous period, when the CO2 levels were 2000 ppm. The trees grew up to 200 feet height. And afterwards, there was a tragedy, calamity. All of them fell down. They were deposited in depressions, and subsequently, coal deposits have formed. Earlier, trees have become present coal beds. So that way, what goes up as CO2 comes down in the form of rains as weak carbonic acids. That carbonic acid, CO2 plus H2O, it becomes HCO3, comes down in the form of rains. And that goes to the sea basins. There, the cations like Ca, Fe, Mg, and all other cations combine with HCO3 and they form thick limestone beds, dolomite beds, and then siderite beds, anchorite beds, like that. So this is a phenomena all through the geological time. We find 200, 300 meter thick limestone beds at all times. So these are the sources for the cement factories nowadays. Okay, so like that, recycling of CO2 has taken place all through the geological past. What happened on the say first day of the birth of the earth, say was slightly later, from 4,000 million years to today, all geological processes have repeated in time, whether it is a plate tectonics or volcanic activity or earthquake or CO2 emissions or deposition on the seabed, sedimentary rock formation, igneous rock formation, metamorphism, ore deposit formation, all things are repeated. This is called a rock cycle. It takes around 500 million years for one cycle to happen. So it's a long history, long story. So that way, CO2, I find that it has been made a scapegoat by these people. They saw the thick emissions from factories and they thought it is getting stored in the atmosphere. I asked a few questions to the climate scientists. What is the residency period of CO2 in the air? Because some gases can stay for a longer period in the atmosphere. No, all gases get recycled annually along with the monsoon rains, except ozone, which is at a higher level, that can stay for a longer time. But all other gases that we release from the surface of the earth, nitrogen or sulfur or phosphorus, boron or iodine, or even carbon dioxide, all these things mix with moisture in the clouds, become weak phosphoric acid or sulfuric acid and nitric acid or iodic acid or boric acid and even carbonic acid. All these things come back to the surface of the earth and they are transported to the sea basin where they get deposited as thick limestone or carbonate beds. This is the story. And you may remember from 2001 onwards, the global warming theory lobbyists, they were telling repeatedly, almost on a weekly basis on TV, that by 2020, 20 major cities, coastal cities in the world will be submerged, including our Bombay, Calcutta, Mangalore, and such. I too participated in TV discussions during those days. And now we are in 2026. 2020 is over, 2026. And how many cities have submerged, have gone under water? No. By 2021, we realized that that was a fake, projection made, that the CO2 levels are increasing, global warming is taking place. Because of that, polar ice caps are melting, and because of that, more water is coming to the sea, and the sea level is rising. Presently, sea level rise has not taken place. Maybe some minor fluctuations are taking place at millimeter level, not at centimeter level or meter level. Earlier periods, we have seen 8 meter to 10 meter of rise or fall of the sea level. Presently, no such reports are there. Nothing like that is happening. In that case, that lobby did a mistake. Uh, that increase in temperature 1.5 degrees or 2 degrees by 2020 or 2030, like that. When they were questioned, they have shifted the goalpost from 2020 to 2050 now. Now they say 1.5 degree increase will be there. And then 2100, 3 degree increase will be there. And we should not allow it to take place. There will be a lot of problems for the life. If 1 degree increase is there, 2 degree increase is there. So we should control the release of CO2. CO2 should be captured and it should be sequestrated. For that, some countries wanted carbon taxation. It was accepted in the beginning. Every country should contribute. But some countries said we are not releasing much CO2. populous countries are releasing, India, Indonesia, China, like that. So they should pay the carbon tax. We will capture CO2 and liquefy it and sequestrate it. So several other attempts were there, including Bill Gates. He wanted to spend this money on capturing, liquefying. But initially he was very enthusiastic, and he got the estimate that to capture all the CO2 in the atmosphere, where several trillions of dollars are required, and then he dropped the idea. So I was asking all through to the climate scientists, if you capture all the CO2 and liquefy it, what will be left in the air? How the trees will survive? What will happen to photosynthesis? So we should not tamper with nature. Nature has got its own way of operating. We have understood this in while studying the Earth internally and externally. Various geo processes are taking place. So when I took the challenge of the Kodagu Kerala deluge on myself without any funding from any agency, I spent my pension money for collecting journals, books, and apps and other things. Even today, I am on the job. So during that time, I disproved these earlier accounts. Then what is the truth? There must be a truth. There must be a cause for the effect that we see. That's a scientific principle. So I wanted to find out the cause. Since 2015, I was collecting day-to-day data of all earthquakes and volcanoes in the world through some apps. I got diary entries. And during 2017 and 18 and 19, I found that there was a hyper volcanic activity in certain places in the world. Now they are not happening. Earlier they had not happened. But that was the period when some major volcanoes erupted, both on land and underwater. On land, we have got hundreds of volcanoes, and believe me, there are thousands of terrific volcanoes underwater. So that's the fact. But what goes on land, on islands, people can watch. Aerial observations are there. In front of every major volcano, there is an observatory. Data is collected every hour, and bulletins are sent out. But what is happening underwater, nobody knows. In plate tectonics, it's a revolutionary theory in geology. It has clarified all our doubts about the Earth. And in that, there are three types of geoprocesses. One is subduction, another is subduction, third one is the transform fault. So the subduction zones are collision zones where plates meet and collide. There major earthquakes and major volcanoes take place. All geologists in the world, including American, Japanese, and all geologists, focused on the subduction zone. Nobody focused on the abduction zone. It is underwater. We don't get any data. There is no observatory under the water. All mid-oceanic rises are abduction zones. It's a well-established principle in plate tectonics. Okay. And we neglected that area, I should say. But somehow, through some apps, I was getting some information about what is going on underwater tectonics and also volcanism. So I started collecting the data, collating the data, and then interpreting it. During that time, I found that there were some major eruptions in Bali. Bali is a honeymoon destination of the world. It's a tiny island, but more than 3 lakh couples go there every season, and all the hotel rooms are full there. But during that time, late 17 and early 18, there were major eruptions in Mount Agung, and there were thick ash layers in a radius of about 10 kilometers. So everything was closed, hotels were closed, airports were closed, and that was the situation. And I will show you one of the slides later. So like that. So now let me show some slides. I request Mr. Kodandram to show some slides. Yeah. So geological truth or perspectives about climate change. This is a typical volcanic eruption, a caldera, a circular caldera or a crater, what we call. okay, with a rim around it. These rims, these craters are mistaken for meteorite impact craters on the moon. Everything is attributed to impact craters, but some of them are volcanic eruptional craters on moon also. Okay, initially we had several of them on the surface of the earth for the first 500 million years. There were craters everywhere, but later on the landform has been modified by various geological processes. We see the present landform as it is, geomorphology, mountains and valleys and such things presently. Otherwise, on moon, no such geoprocess or lunar process has taken place, and it is a frozen surface. That is why we see craters everywhere. No mountains and no valleys, no rivers, no oceans. So nothing like that. But both have got a similar history. The starting point was the same. The date of birth of both moon and earth are the same. But on earth, several changes have taken place. At least 6 to 7 tectonic cycles have taken place, and that has benefited the mankind. Several mineral deposits formed because of these geoprocesses. Anyway, next. Yeah, ours is a beautiful Earth, the blue planet. The other day we saw a nice picture shown by Artemis 2 crew from the other side of the moon. They have taken a picture, almost a similar picture. The beautiful Earth, the only livable habitat for mankind in our solar system. We don't know how many such planets and livable conditions are there in other systems, in other stars. But in our solar system, of all the planets around us, ours is the only planet with ideal, conducive living conditions, ideal temperature, lot of water, lot of oxygen, and a protective layer of ozone, and several, and a nice atmosphere like that. Next one. Well, talking of volcanoes, these volcanoes are there from day number 1 in the history of the earth, and even today volcanic eruptions are taking place around the world. Normally 40 to 45 volcanic eruptions take place on any single day. I've got the app which gives me information within half a day, because the scientists have to go to that island, collect the information, collect the photograph and the sample of the lava, collect the gases, analyze, and put out the bulletins. It takes half a day. But for any earthquake in the world, the information comes to my mobile within 5 minutes. So that type of up-to-date, state-of-the-art scientific connectivity is there with the cooperation of all geological agencies in the world. So I am able to carry out this research and enrich myself and upgrade myself as a scientist because of the help from this app. So although I got the ideas, the support comes from this app. It is called Volcanoes and Earthquakes. Anybody can download it and then monitor the events around the globe. So these volcanoes have played havoc in the past. You know, they have destroyed civilizations. For example, the Machu Picchu, Peru, that Sabancaya volcano was responsible for destroying that civilization. And also, people have heard of or read about it in the textbooks. Pompeii and Herculaneum, Vesuvius, 79 AD, that destroyed 2 major towns because there was a sudden volcanic eruption at 10 o'clock in the night to a great height. It is supposed to be volcanic eruption index of 6. 7 is the super volcano. That was almost a semi super volcano, and that destroyed those 2 major towns. So hundreds of examples are there for volcanic eruptions and destruction, and they have also shaped evolution in the course of time. So we all exist today. Tomorrow we can be destroyed or perish because of volcanic eruptions. That is why the next quote, please. That is one of the quotes is there. Yeah, I'll come back to this one. One more quote is there. Durant's famous quote. Next one. Yeah, this one. That quote. Previous.
Back.
Yeah.
Hmm.
Civilization exists with geological consent, subject to change without notice. Things can happen without notice. An earthquake can strike 7 or 8 or 9 without giving notice. Sometimes they give notice. We have to read the notice properly. Symptoms we have to understand. Volcanic eruptions we have to understand. Otherwise, civilization can be wiped out with one super volcano. Such major, super volcanoes are there in the world. Luckily, some of them are silent now, and some of them are active to some extent. They can go to an extent of 100 kilometers height. The gases can be hurled into the atmosphere to 100 kilometer height. One example is the 1815 1815 Tambora volcano. When it erupted, it reached a height of 92.5 kilometers. It there was a total chaos all over the world for 6 years from 1815 to 1821. It's a long story. I request the listeners to visit Google and then read about Tambora. That was the period of major calamity. All kinds of calamities. Heavy floods were there, famines were there, plague and cholera were there, migrations were there, climate related migrations were there. Like that, hundreds of cases are there. I can say only this much, that civilization exists with geological consent. Otherwise, we will not be there tomorrow. Like earlier mass extinctions, human beings can also be wiped out. Anyway, earlier two, please. We'll go back to the earlier two. The global, temperature increase. And then one more. I was telling about the Al Gore and Pastricha team, which floated that idea of global warming. Because of that, all countries were alerted, and there were lot many efforts. All of you are aware of it. One lobby I want to remind about Greta Thunberg. You have heard about that 16 years old girl, Swedish girl, high school student. Now she must be 22 or 23. So keeping her in the front, the climate lobby floated all types of theories and then created a sensation. And the climate change is still, working in some countries, but some countries have rejected it. One rejection major I want to mention: 2015 Paris Accord, COP26, 195 countries signed, but America did not sign. Donald Trump did not sign. Okay, whatever may be his, erratic uh, ideas and other things, but one or two things I appreciate. One is building the Mexico wall to stop migration. Second thing about his clear concept about climate change. The truth. How his ancestors, around 3 lakh Germans, migrated from Germany to America in 1815. There was a great famine in Europe. Nothing to eat almost. Okay, that time they migrated. And he knows that 1815 Tambora volcano was responsible for that situation. So he said, these are natural changes and man has no role in climate change. Okay, 26, COP26, COP27, to some extent, people tried to convince the countries to pay the tax. In 27, our Prime Minister Modi participated, and he said, we are not able to pay that much of money. Instead, to switch over to alternative energy sources, you pay the money. He wanted UN to pay the money to poor countries. That time, the advanced countries were not ready to pay. Then there the matter ended. COP28 was a failure. COP29 was a failure. Now recent COP30 is total flop. Now nobody talks about climate change, no global warming, and no lobby. Everything has become silent. That girl, she has switched over to other areas. So this is the kind of story behind climate change. Anyway, this 4 major reports I mentioned, averages. Averages are averages. Average temperature, average rainfall, average sea level rise, average glacier melting, averages are average. That did not carry any meaning, any sense. So this IPCC, FCC and others were rejected. Now the climate change theory is rejected. No greenhouse effect. Carbon dioxide 330 to 440 ppm. If that is the cause, I ask the question, 440 parts per million presence in the atmosphere. Out of million particles, 440 are CO2. What about the rest of the molecules? Nitrogen and H2O, methane, and all other gases. What is their role? Do they cause warming or do they cause cooling, like sulfur dioxide, like what they call aerosols? So what is their role? It is not defined here. But they got out of only CO2 and they made a big show, big projection. Now it is rejected. Okay, next one. Next one. Next. Yeah, the earlier one. The red one. Earlier. Yeah. Now, 2018, I have got the record in Kilowa, Hawaiian Island. This is from Hawaii, edge of the Kilowa Island. It's a major volcano center in the world. It's a hot spot. It's a plume, what we call that. And there, unusually, a lot of volcanic activity was there. A lot of magma rose from depths to the surface. Every time a magma batch comes to the near surface, every kilometer, there will be an earthquake of 2.5 or 3 magnitude. And more than 6 or 7 or 8 or 9 are tectonic earthquakes in collision zones or in subduction zones or transform faults like Afghanistan or Burma or Indonesia or Philippines, like that. Okay, these minor volcanic earthquakes, I was wondering every day, 500, 600 earthquakes were taking place. Altogether in a month, 15,000 minor earthquakes were there. That means so much of magma has come to the surface, and that gushed out in the form of lava fountains through 29 fractures, about half a kilometer to 1 kilometer long fractures. And all that lava flew like a river for 3.5 kilometers from the crater, Kilauea crater, to the edge of the ocean. And that fell into the ocean. When that hot lava, 1000 to 1200 degrees centigrade, touches sea water, the sea water gets evaporated instantly. So much of vapor was generated that went up, formed clouds. Well, this is Kilauea situation, one situation. Then at the same time, I mentioned about Bali, Mount Agung. Then one more center was there in our south of Arabian Sea, North Indian Ocean. Near Mauritius, there is one more major eruptional center called Pito de la Fornesa, tip of the furnace, that is the meaning in French. So that also started erupting like this. Nearly 9,000 minor volcanic earthquakes were there in 1 month. That also erupted for 3.5 months. And a lot of lava came out and flowed for nearly 3.5 to 4 kilometers and fell into the sea. And there also situation like this, lot of lava, vapor was generated and released into the atmosphere. So like that, at several places, one more is west of Spain. There are Canary Islands, La Palma, another volcano erupted. Similarly, so that fell into the sea and a lot of vapor was generated and that went up and formed clouds. Condensation, precipitation, because of volcanism, can take place very quickly and fall down there itself as rains. Sometimes they are transported along the tropical equatorial region. Incidentally, most of the volcanoes, major volcanoes, are located along the equatorial zone, along the tropical zone. And once the vapor comes into the tropical zone, from north to south or south to north. They converge along the tropic line of tropic. That is called intra-tropical convergence zone, ITCZ. There's a common term used by the meteorologists. So that can travel around the globe. It can go to, okay, depending on the speed and direction of the wind. So like that, that travel towards east from Hawaii, and then from Agung towards west. It all depends, periodically, not simultaneously, and all of them converged on Western Ghats. Coming from the west or coming from the east, Western Ghats, Kerala and Karnataka, to some extent Maharashtra, were the recipients of these extra vapor or moisture or rains during that time. Unusual heavy spells were there in 18 and also 19, and that was the reason for the heavy rains. This is the story behind this mystery, what was called. And by February 2019, I understood this phenomena, this cause, and I gave a press statement in April 2019 that things will be repeated in 2019. Deluge like 2018. Nobody believed me because this was for the first time in our country, probably first time in the world, giving a precaution or a bulletin or a warning 2 months before the monsoon. It was surprising. I took a bold decision to go to press and give a statement in the TV and also in the press. Ajit Hanumakkanavaru called me to Suvarna and grilled me for half an hour. Sir, how do you say that before 2 months that there will be heavy floods in Kodagu, Kerala? He grilled me. What is your evidence like that? Before that, my wife also asked, sir, what is, she said, what is going to happen tomorrow? We can't tell. Then how are you sure about telling 2 months in advance? Then I explained everything. I told Ajit Hanumakkanavaru that this is the phenomena, this is the cause which was behind 2018.
There is some voice break from last 1 minute. Probably Wi-Fi issue. Now it's okay, sir.
Now it's okay. Actually, I was using the phone before the talk also. Temperature is slightly high. It is showing. I put a wet cloth around it. Let me see. It should bring down the temperature. Okay. So the like global warming, mobile warming is also taking place. So like that. But in 2023, I found that, of course, these major global volcanic hyperactivity was not there, but some of the active volcanoes around India, in Sumatra and Java, Indonesia and Philippines, and West also, Arabian Sea also, floor of the Arabian Sea also. For example, Carlsberg Ridge and Chagos Islands, they were contributing to the disaster. So that year, 2023, most of them were inactive on a low key. Then I thought their contribution of vapor into the atmosphere will not be much. Then I predicted a deficit year, deficit monsoon for India. It happened that way. There was a great deficit. We had to struggle for drinking water in Bangalore and also all over the country. 24, again I said it's a normal year. 25, I said slight deficit will be there because the number of volcanoes erupting around India and the level to which they are erupting and the amount of vapor release, etc., were not normal, slightly less than normal. I predicted a slight deficit last year. It happened that way. Karnataka and central India, there were heavy floods. There is another reason for that. Reason to all the listeners, I will tell about it. So last year, Chamarajanagar, Mysore, and Mandya, Bangalore, there was less rains. So even then, there were heavy rains along the Western Ghats, North Karnataka, and Central India. And enough storage was there in KRS. In the month of June itself, KRS got filled up, and now we are having enough water. It can take care of us for some more time. Anyway, the reason for unusual floods in Madhya Pradesh, Maharashtra, and all such places was, you will be surprised to know, for the, I think no other earth scientist has given this explanation so far. East of Kamchatka, Russia, around 150 kilometers east of Kamchatka, on the sea floor, there was a major earthquake. 8.8 magnitude earthquake was there. So it is not uncommon on the sea floor. Such things can happen. Sumatra, it happened in 2004 and 9.2, and tsunami was there. You know that. So here, Kamchatka, following that 8.8 magnitude earthquake, there were 3,000 aftershocks for about 20 days. And out of 3,000 aftershocks, nearly 2,000 are tectonic and nearly 1,000 are volcanic earthquakes. We discriminate between these two based on the depth of the origin of the shock waves, earthquake waves coming generated, or the rupture taking place. Less than 10 kilometers, normally it's a volcanic eruption. Magma tries to come up to 9 kilometers, 8, 5, 4, 3, 2, 1, and then comes out and spreads on the ocean floor. It's a great phenomena called ocean floor spreading that revolutionized our ideas. Anyway, around 2000 are deep focus, around 150, 200, 300 kilometer earthquakes in that Kamchatka earthquake. So at least 1,000 earthquakes, volcanic earthquakes, 1,000 times the magma has come up and spread on the ocean floor itself. 1,000 degrees coming and coming in contact with seawater, instantaneous vapor generation was there, cloud formation was there, that traveled towards south and then west via Philippine Sea, and then our Taiwan, then Thailand, and then Andaman Sea, and then towards India. This is the usual route. Every year we are seeing the eastern flow of clouds. The BBC shows the circulation of clouds in their weather bulletins, in every news bulletin. So like that, for about 1 month, this type of heavy cloud flow was there from the east towards central India, North India, and then South India to some extent. Hyderabad received a lot of rains. There were floods in Hyderabad. North Karnataka, there were floods. These are not regular part of the monsoon. These are contributed by the volcanoes. Monsoon is driven by evaporation and evapotranspiration of normal seawater going evaporating and going up, and then trees and human beings, transpiring or releasing vapor. These are normal. Above that, these volcanoes also generate once in a way and release a lot of vapor, which are responsible for floods anywhere in the world. Behind any such floods or disasters, unusual volcanic activities. This is the main point I want to focus. Next one, please. Yeah, this is a major eruption in Sinabung in Sumatra, very close to us. We have only one volcano of our own, Indian volcano, that is Barren Island, 135 kilometers northeast of this capital of Andamans. What's the name? Capital of Andamans?
Port Blair.
Sleeping out. Port Blair. So 135 kilometers northeast of that, this barren island is there. It erupts once in a way. It is the same latitude as that of Bangalore. And whenever it erupts, there will be rains in Bangalore. It is not a coincidence. It's a process taking place. Anyway, this cloud, Sinamung, gave a lot of floods, some problems in 2010. Okay, then you see this cloud, gases and other things, nearly 70% is water vapor coming out of the magma chamber. Magma is the molten rock inside the earth, below 40 kilometers, right up to the center of the earth for about 6371 kilometers, minus 40 kilometers. The entire thing is molten rock. And once in a way, the molten magma comes up to the surface and comes out as volcanic eruptions. Sometimes the magma can gush out at red hotspots or plume centers from a depth of 150 or 200, 300, 400 kilometers. Large volumes of magma comes out and pours out all of a sudden, and that creates unusual climate changes, because climate or weather, what we see normal, undisturbed, what we are seeing today, it is generally undisturbed. But whenever such things happen, huge amounts of vapor and dust and gases released, they could disturb the whole setup. The temperature, pressure, humidity, dust content, speed of the wind, direction of the wind, like that, everything is disturbed. If one volcano happens, around that area, disturbance. If 10 volcanoes erupt, nearby areas, you can see the disturbance. Suppose simultaneous eruption all over the world, you can imagine the calamity. It happened in Cretaceous Tertiary period, leading to mass extinction and then total calamity 65 million years ago. So out of this cloud, 70% is water vapor, and then 20% is ash particles, fine particles. Big ones fall down quickly, but these fine particles can go up to great heights. Tambora, 92.5 kilometers, Krakatoa, very close to us, 45 kilometers, and then Indonesia, Semeru, and then several of them, Athol, and then Ulawun. I can quote tens and hundreds of examples. Sometimes they go up to 20 kilometers, 30 kilometers, 40 kilometers, and up to 10 kilometers is our troposphere, where the normal monsoon activity takes place, wind movement takes place, and everything comes down. If it crosses the tropopause and goes into stratosphere, there it becomes slow, because the wind is less, atmosphere is less, movement is less, and it can travel slowly around the globe, and it can encircle the globe several times, sometimes 6 to 7 times. So they can cause the effect. They can lead to the effect, heavy rainfall or cooling or such things later. Today it has happened, it has gone up, it can stay there for 1 year or 2 years and then cause the effect later. So this type of delayed effect is also there. One classic example is Mount Pinatubo in 1991 in Philippines. Lot of sulfur dioxide was released, and that led to cooling of the earth for 2 years. So like that. So this is the Mauritius, this Fornesa. It's an island, a French colony, and lava flowing like a river. Next one, please. I've got one more important thing to tell before we close. This is Mount Agung. Very rare situation, very rare photo. Why it is steam? When the magma comes up to a depth of 2 kilometers, 1 kilometer, it reacts with groundwater and only steam comes out through one vent. Through another vent, the magmatic gas O2, SO2, and all other gases, as mentioned in the atmophile group in the periodic table, all gases come out. In fact, magma chamber is a mini representation of the earth. The rocks are totally melted and it becomes a liquid. So like that, magmatic gases lead to several problems of their own kind. Steam can give rains there itself, or 100 kilometers away, or 1,000 kilometers away. It all depends on the force with which it comes out, and the speed of the wind and the direction of the wind, like that. And India, I would like to mention, especially here, that India is in a very advantageous position. It has got two entry points. One is the Bay of Bengal, and on the west side we have got the Bay of Gujarat or Bay of Karachi. It is called Arabian Sea. It should be called the Bay of Karachi appropriately, or Gujarat. Both are bays from the equatorial region, from the main ocean, Indian Ocean. Things move up and enter India from the southwest, that is called southwest monsoon, and enter India from the southeast side, and that is called the southeast and sometimes northeast winds. Two monsoons for India. It is in an advantageous position. That is why we have the bounty here throughout the year. Sometimes we receive rains. A lot of agricultural output is there, and people are happy here. That is why people from all over the world, from problematic areas, they want to come and settle in India since historical times. Anyway, who has not come to India, so to say, except Russians? Otherwise, you find Dutch, Portuguese, Germans, and all kinds. In the name of trade or something, they come and settle here. Okay, anyway, next one. This is the situation around us. The plate tectonics earlier. Yeah, the plate tectonics. The eastern side, we have got Sumatra, and then Java, Indonesia, Philippines. All these influence the climate of India. From west side, this blue line, Arabian Sea, these are very important areas. I am trying to understand what is going on the sea floor, mid-oceanic rises, Carlsberg Ridge, Chagos Islands, and then Mauritius, and then Hard Island, and then Triple Junction, Rodrigues Triple Junction, western arm, and then eastern arm of the Indian ridge, Indian Ocean ridge, like that. This is the area. Whenever there is a spurt in volcanic activity in any of these areas, the vapor is generated, comes up and moves towards India, especially along Western Ghats, Kerala, Karnataka, Maharashtra, and sometimes in Gujarat. So this is the phenomena. And sometimes they go towards eastern margin of the Africa also. In 2019, there were 3 cyclones in the Arabian Sea, and they moved towards west, and they create a problem in 3 countries, Mozambique, Mali, and Zimbabwe. So suddenly there were three cyclones. In 2019, there were 9 cyclones around us, 6 in the east and 3 in the west. That was a special year, as I mentioned. And a similar event took place in 1924. 1924, Kerala and Kodagu witnessed similar disasters, and Gandhiji collected 6,000 rupees from his Young India through his magazine, and then sent it to the victims in Kerala. So that was the period. It repeated in 2018. So things repeat in time. That's an important geological principle. There is a cyclicity of volcanoes, earthquakes, and everything, and over time things repel. North pole becomes South Pole. South can become North Pole once again. Continents collide, break up, assemble, and move in different directions. And in the process, several mineral deposits form. These volcanoes bring out a lot of nutrients and important mineral deposits from deeper bowels of the earth. All metals, metallic ions, come out through volcanic eruptions, through the liquids, hydrothermal solutions, or directly or indirectly. Next one. Next one, please. Yeah, this is Mount St. Helens in 1980, America. It reached a height of 14 kilometers. That was a disaster. So instead of going up, the liquid, the lava portion started moving towards east. By breaking the eastern portion of the crater, everything flowed suddenly for 12 kilometers, where a geologist camp was there. And he predicted by studying every day that by tomorrow morning, 9 o'clock, there will be eruption. It exactly happened at 9 o'clock, but it flowed towards his camp and he was killed in the process. St. Helens. Next. Next. Well, this is the Kilova I mentioned. hundreds of lava fountains rising to 100-200 meters, like Brindavan Garden water fountains coming out through 29 fractures. Okay, so for about 3.5 months, and then reach the ocean, generated vapor, and then it all looks like a story. But when you understand nature, this is how happening. The Earth is one unit, very dynamic unit. It has got 4 spheres. Lithosphere, this rock layer. Above that, we have got water sphere, hydrosphere. Above that, we have got atmosphere. And including all these ones is the biospheres. So, biosphere. So, no single isolated study can give the actual picture. An integrated study will give you the total picture. Now the atmosphere scientists, IMD and such people, are not doing this kind of integrated study. They think that the air exists on its own. Atmosphere is an independent sphere. No, it depends on changes in the lithosphere like this, and also on the hydrosphere, the water layer, sphere. So they influence the atmosphere. So that is why I've connected up geology and meteorology, and I call it geometeorology. It's an offshoot of the plate tectonics theory. My theory is a revolutionary theory in understanding the whole process. What we had ignored, the sea floor, I am throwing light on that. And I have published a paper. It has gone to all countries, and there's a tremendous response, appreciation for my new idea, new concept. And this will catch up in the coming years. Next. Next one. Yeah, this is the one I mentioned. And this was the earlier edge before the eruption. After the eruption, a new beach has developed, 350-meter long. Because once the lava falls down, the lava gets solidified at this point, some part of it. It becomes hard. And like that, every successive eruption, new land grows, leading to increase in the length of the island. 350-meter increase was there. New beach developed here. This is Hawaii. So instantaneous generation of vapor you can see. Next. Next. Well, okay. And today, in a passing, I will mention about the generation of coronavirus through geological process in a natural way. And all of us know that the Wuhan laboratory was blamed. Okay, that is not the fact. International Court of Justice, formed 7 committees to come out with the truth. They blame on Wuhan laboratory whether it is true or not. 7 out of 7 committees, 4 said it is natural, 2 said it is laboratory, 1 said neutral. We can't say what is what. 4 said it is natural. Natural in the sense, earlier periods, there were pandemics and epidemics. You heard of plagues and choleras and influenza, Spanish fever, malaria, smallpox, like that. They are also viruses. They also belong to corona family, but slight variations. So 1601, there was extensive plague and cholera all over Europe and China. And what was the reason? Where was the laboratory? Which laboratory was there? 1950 onwards, there are virological laboratories. So earlier, natural phenomena was there. Natural phenomena was very rare situations of volcanic eruptions. When volcanic eruptions take place, okay, in one of the slides, I can explain if you go back. So a lot of SO2 is released instead of CO2. During that time, there will be a lot of purple colored volcanic lightnings, just like white lightnings in our head in Bangalore, atmospheric, meteorological. There will be lot of, this one, yeah, earlier, this one. Especially on January 12, 2020, the Stal volcano erupted in Philippines to a great height of 46,000 feet. And it was mostly SO2, and a lot of charged particles were there. and there was an instantaneous discharge, and this kind of high voltage lightnings were there, millions of volts simultaneously. And I mentioned earlier that this plume above the erupting volcano contains all gases coming out of the magma chamber, and they combine instantaneously to form molecules. H plus O, S2O, C plus O, CO2, or nitrogen and oxygen, or H plus S, S2S or HS2, like that combinations take place. Acids form, nitric acid and several others. Similarly,
Sir,
I
sorry,
also
sir.
have the opinion.
Time is up already, 8:45.
Okay, I will close it.
Yeah.
Okay. So amino acids can also be generated, and molecules enclose that amino acid. And once the lightning is there, that energizes the molecules and they become viruses. That was the reason for the coronavirus, the pandemic that we witnessed. Before Tal, there was a Ula one in November 19. So I have given a lot of explanation for this. We have got a paleontology evidence for saying so. In geology, we conducted an experiment. In a bowl, we took the carbonic soup and passed the electric arc. Amino acid was generated. And energy gives, by natural process, gives life to the molecules. One example is, take a chicken egg and keep it for 1 or 2 months or 3 months away from the heat in a cupboard. Nothing will happen. Instead, keep it under a burning bulb. Because of that heat, the egg hatches and the chick comes out. That heat given by the lightnings makes the molecules viruses, and this is the phenomena. This is the process behind any types of diseases in our earth. For example, in June, July, in Bangalore, there will be a lot of viral fever. There will be a long queue in front of the clinics. Doctors will be happy. It's a bumper period for the doctors. How that lightning above our heads generates viruses locally. It can happen in Mysore, it can happen in Arsikere or Delhi or Chennai and everywhere simultaneously. So lightnings create molecules, energize the molecules, and then they become viruses. This is geological, and this is the way. Earlier also, thousands of times, epidemics and pandemics have happened. This is not the first time that corona has happened. Hundreds and thousand times it has happened earlier. And this is the geological process behind all these things. Thank you very much.
Sir, it was wonderful. You have removed that carbon theory and its climate change and all is a bogus one. It's really a wonderful statement from you. I think we will straight away go to Bharathraj to give vote of thanks. We are left with no time for question answer sessions.
So it was a wonderful session, sir. We have opened our eyes on very new concepts and removed some of the myths prevailing in our minds about sea level increase, global warming, and the greenhouse effect, and all those things. You have given us a true information. So we are indebted to you, sir, for your wonderful and informative talk and so many things. And the end of this thing, what you have given us the information about the how virus are developed by the lightning and how epidemics are this thing with the geological reason. So all these days we were not knowing this reason. So you have thrown a light on a new subject and enlightened us. It was a wonderful session, sir. Thank you very much for being with us and giving this wonderful session. Thank you all. I thank all the participants.
Thank you for the opportunity given to me. Thank you very much.
We are thankful to you, sir. So thank all the participants. I thank all the participants, and I expect your cooperation for our next sessions like this. So I thank you all once again. Good night.